Hello, class. We are talking about 9b, the inverse power rule today in calculus. Actually, we already talked about it in 9a, so this is just a little more fleshing out the details, maybe trying a little trickier problem, something like that. All right, so let's see what happens here. All right. So the inverse power rule, the antiderivative of x to the n, so it's the number in front, 1 over the new exponent, x to the new exponent. And antiderivatives go up. So to get the new exponent, you take the old exponent and add 1. So, problems don't get much easier than these. So for review of the basic inverse power rule in a simple problem, it's 1 over the new exponent, 1 over 3, x to the third, plus c for good measure. We need a c because there could be a number at the end that you can't figure out because the derivative of any number is 0. This one, 6 over the new exponent, x to the new exponent. The new exponent goes up by 1, plus c for good measure. 6 over 3 is 2. That's our final answer. All right, let's try these. Evaluate the general indefinite integral. So this is an integral. It's indefinite because we're not sure what the answer is, plus c. So it could be anything. It's not a definite number. It's indefinite. When we graph it, we wouldn't know how far up or down it is. Okay. We do not like division, so we will flip this to the top. So we get 5x squared plus 3. Now we can take the antiderivative. So it's 5 over the new exponent, x to the new exponent, and 3 becomes 3, whatever the variable is, 3x plus c for good measure. All right, let's try this one. 1 over the square root of x. So the square root of x is the same as x to the 1/2. Now we don't like the division, so we flip it to the top, and it becomes x to the negative 1/2. Now we can take the antiderivative. So it's the number in front, which is a 1, over the new exponent. Let me think about this one. So negative 1/2 goes up by 1, and 1 is the same as 2/2. So negative 1/2 plus 2/2 is positive 1/2. So it's 1 over the new exponent, x, to the new exponent, plus c for good measure. Now, 1 over 1/2 is the same as 2x to the 1/2 plus c. Or, if you want to write the 1/2 as the square root of x, that's also acceptable. So either notation is just fine. And that smudgy thing is a 1/2. Okay, let's try this one. All right, the first thing we're going to do is rewrite the cube root of x squared as x to the 2/3. Okay, now we can happily take the antiderivative. So the antiderivative of 1/2 x to the 2/3. So it's 1/2 over the new exponent. Let's see. The new exponent, well, 2/3 is going to go up by 1, and 1 is the same as 3/3. So 2/3 plus 3/3 is 5/3. X to the 5/3 Now, the derivative of e to the x was e to the x. So the antiderivative of e to the x is also e to the x. Don't forget your c for good measure. Okay, now, 1/2 over 5/3. That looks bad. Division is the same as multiplying by the reciprocal. Minus e to the x plus c. Okay, I think we're about ready for our final answer. 1/2 times 3/5 is 3/10. 3/10 x to the 5/3 minus e to the x plus c. All right. Let's try the next one. The antiderivative of 4, let's see, we don't like this division. So the power rule doesn't apply to division, so neither does the inverse power rule. So what we're going to do is we are going to distribute the 2x squared to every term. So it's 4x to the 10th over 2x squared plus 14x squared over 2x squared minus 2 over 2x squared. All right. Now I have more divisions, but now I can simplify each one. So 4 divided by 2 is 2, and x to the 10th divided by x squared is x to the 8th. So I've got 2x to the 8th, 14 over 2 is 7, and x squared over x squared cancels. So I have just plus 7. 2 over 2 cancels to a 1. So now I have 1 over x squared, but I can flip that to the top and get minus 1 x to the negative 2. This looks fine. I can now take the antiderivative. So it's 2 over the new exponent. 8 goes up by 1 to a 9, x to the 9th, plus 7. Oh, what variable was I taking the antiderivative with respect to? It was respect to x. So there technically should be a dx here and here. So what's the antiderivative of 7 with respect to the x variable? 7x minus 1 over the new exponent. Negative 2 goes up by 1 to a negative 1. All right, so now I have 2/9 x to the 9th plus 7x. 1 over negative 1 is negative 1, minus a negative 1 is positive 1, and then x to the negative 1 flips. So this is 1 over x plus c. Okay, let's try the next one. The antiderivative of 2 sine of y minus 3 with respect to y. Ooh, tricky. Okay, it looks fine. Now, the antiderivative of the sine is the cosine. Or it's the negative cosine. Wait, we need to check. Okay, class, here we are. I had a little trouble finding my purple sheet, so I had to go print one out. So this purple sheet is not purple, but it does say purple sheet, so I think we're set. All right, the antiderivative of the sine. Okay, so the antiderivative of the sine is the negative cosine. So the negative cosine times 2 would be negative 2 cosine. the antiderivative of 3 is 3y plus c for good measure. That was it. There's no intermediate steps to show. All right. If you remember, the derivative with respect to x of the natural log of x was 1 over x. So therefore, the antiderivative of 1 over x would be the natural log. Okay, the rest of these problems, you want to flip to the top. So this is the same as the antiderivative of x to the negative 2 with respect to x. So we didn't flip this one to the top because it was our special case. So A is our special case. The rest of them will flip to the top. So the antiderivative of x to the negative 2 with respect to x is 1 over the new exponent. Negative 2 goes up by 1. Negative 2 plus 1 is negative 1. X to the negative 1. So that's negative 1. And then x to the negative 1 flips to the bottom. So this is negative 1 over x plus c. This one, flip it to the top, x to the negative 3 is 1 over negative 3 goes up by 1 to negative 2, x to the negative 2 plus c. We'll make that look better. 1 over negative 2, can't do much with that. X to the negative 2, flip to the bottom. So it's 1 over negative 2x squared plus c. Okay, that should do it. Give these
problems a shot, see what happens, check your answers, and you can always go back to the video, hit pause, rewatch some of it if needed, if necessary. Good luck.